Hey everyone, welcome back, and today let's solve Leetcode problem 3355 titled Zero Array Transformation Part 1. So we're given an integer array nums of length n, and we're also given a 2D array queries, where queries at any index I is equal to a sublist of length 2 for L sub I and R for that index. Now, for each query at index I, we need to select a subset of indices within the range from L sub I to R sub I in the input array nums. And we have to then decrement the values at these selected indices by 1, and a zero array is an array that's defined to be all the elements in it having equal, or rather being equal to 0. Now we need to return true if it is possible to transform nums into a zero array after processing all of the queries sequentially, otherwise we have to return false. Right? So in example 1, we have our input array nums to be 1, 0, 1. In this case, we have three indices of 0, 1, and 2, and we only have one sublist, if you will, in our input queries of index 0 to 2. Right? In this case, we actually do have the possibility to transform the input array nums to be completely, or rather become a zero array where all the elements in this input are actually completely zero, and that's why in this case we have an output of true. And the way we could do that is for I equals 0, meaning for the actual first index or 0th index, if you will, that we address in our queries input, we can actually select the subset of indices to be the entire array, meaning from index 0 up until index 2 inclusive, and decrement all the values at these indices by 1. If we do that, we see that 1 minus 1 is 0. Cool, 0 is already 0, we don't need to do anything there, and 1 minus 1 is 0. Guess what? All the values would then be 0 if we select that indice from 0 to 2 of indices of our queries. And notice how our queries does support that, because it does give us the option where L sub I is 0 and R sub I is 2. So we really just select the subset to also be 0, 2, decrement all the values in the input array nums in that range of indices, because it is the entire input array nums to be decremented by 1. We get a 0, 0, 0 resulting array. That is a 0 array, and so we do output true. In example 2, we have our input array nums to be 4, 3, 2, 1, and in this case we have two different sublists or ranges, if you will, of indices in our input array queries, 1, 3 and 0, 2. Now in this case we actually have an output of false. Why is that? Well, because first let's continue that sequential order of where we address the input array queries. First we'd address this 1, 3 query. Right? If we select the subset of indices to then be, okay, well, the whole 1, 3 to delete as many elements as possible, or rather decrement as many elements as possible to have the highest chance of making the input array nums a zero array, okay, we'd select the subset of indices to be 1, 2, 3 or 1, 2, 3. And doing that, we could decrement those values, which would be this 3, this 2, and this 1. Basically everything but the 0th index. Then we'd get 4, 2, 1, 0. Great, okay, so the last element became 0, but even if we addressed the second query to choose all the indices 0, 1, and 2, we would get 3, 1, 0, 0. Not all of the elements in 3, 1, 0, 0 are 0, and hence in that case we couldn't really do anything, even if we use all the indices possible, or rather all the ranges of indices in our input array queries optimally, selecting all of them and decrementing all of them. Even then we wouldn't be able to actually achieve a zero array, and because of that we would actually have an output of false. So for the constraints here, we see that the length of our input array nums is going to be between 1 and 10 to the 5th power, or any value is also going to be in that range, except it can also be 0. The length of the queries input array is also going to be between 1 and 10 to the 5th power. Its length is guaranteed to be 2. Basically, again, that's kind of subset of range of indices that we can choose from L sub I to R sub I, and L and R, those values, are also guaranteed to always be valid, meaning they're between 0 and the length of our input array nums, which really is going to kind of guarantee that there are always going to be indices that we can actually choose from our input array nums, right? Which leads us to the main observations that we really need to make to solve this problem in the most efficient solution. And the first one that we can really make is that applying each query would always allow us to decrement values within that specific range, like we saw in the examples, and of course what the problem statement confirms. Now we want to actually efficiently track the cumulative effect of all of these queries, meaning decreasing values in all of those query ranges. And so we can use something called a difference array to keep track of that cumulative effect for all the indices across the entire input array, right? That's the whole point of it being called a difference array, where the whole concept or kind of theory of a difference array is we create that extra or auxiliary array. We'll call it difference or diff if you will. It doesn't really matter. It's going to have length n plus 1, where n is going to be the length of our input array nums, and it's going to be initialized with all zeros for the initial differences of each index. And for each query that has a range of L to R of indices, we can increment diff at L by 1 and decrement diff at R plus 1 by 1, because that allows us to actually compute the number of times that each index in the input array nums is decremented by calculating that kind of prefixed sum of diff. And the whole point of kind of using that difference array is that it allows us to really perform those range updates of differences, if you will, in constant time for every query that we address, again, in that sequential order. And after we actually process all of those queries, and then we can really just use those counts or differences to actually determine the total decrements that we apply to each index, basically just by computing the prefix sum of the entire diff array, right? So let's go ahead and get into how this solution works as a whole here. And the first thing that we're going to do, like I kind of glossed over in my solution here, let's get into just be very straightforwardly the length of our input array nums. Right, this is really just to help iterate over and create our difference array, just less typing, just to make it a little bit more efficient typing wise and elegance wise, because typing out length of nums gets kind of annoying at times, right? So we just get the length of nums stored in the variable or integer n, and here we actually then initiate or define our difference array, right, to actually help us account for the different differences and counts the total times we decrement each index and see if it actually is valid to make our input array nums a zero array. So it's going to be diff, like I said, it's going to be initialized to all zeros with a dimension of n plus 1, right? Where basically, again, it's going to have n plus 1 zeros to start off with. And the whole reason of why we have n plus 1 and not just a dimension of n is because that extra element will actually help us handling the decrement at r plus 1 without any index errors. Because if we're at the last index and we don't have one extra index at the end, we'd actually get an out of bounds or index too high error, which obviously is something that we do not want. Right, so now let's actually begin iterating over the queries and unpacking the left and right indices as we actually do that to account for the number of times we decrement indices in that range for each query accordingly, right? And the way we can actually unpack in Python is, in this case, we're guaranteed that every sublist in the input array queries, or every index, if you will, in the input array queries is going to have a list of length 2, and so we can use 2 iterators for our L and R values in each iteration. So for every L and R in the input array queries, again, we're basically just unpacking it using these 2 different pointers or iterators, if you will, that we call L and R, unpacking the left and right indices for each range or index in the input array queries. We'll get diff at L and increment that by 1, right? Because we're incrementing it by 1 to indicate the start of a decrement range starting from L going up until R. Right? And similarly, we're going to get diff at R plus 1, and in this case, instead of incrementing it by 1, we're going to decrement it by 1. And the whole point of this is because that's going to indicate the end of a decrement range, and so we have to increment diff at R plus 1, the outside element of this range, and the next outside element by 1, because that indicates the end of a decrement range. Right, so once we actually do that, now that's really basically it for that initiation and diff, decrements, if you will, for the queries of what we actually get from the range of queries. And here we actually can initialize now a current variable. The whole point of this current variable is to actually keep track of the cumulative sum, or the prefix sum, if you will, of the difference array, or diff, representing the total decrements that we actually applied up until the current index, to actually determine, as we iterate over the input array nums, to see if it actually is possible to make it a zero array. Right, so once we actually initialize current to be the current prefix sum of diff, now let's actually begin iterating over our input array nums, right? Or rather, more specifically, each index of the input array nums, which is basically just for I in technically the range of the length of an input array nums, but really just for I in the range of n. Again, another use case of that n integer, just to go through each index of the input array nums, right? And for each iteration, or every iteration in this for loop here, we're going to get the current prefix sum, and as you may imagine, we're going to add on difference at index I, because again, it's going to be the kind of prefix sum or cumulative sum of the difference array. And so we have to update it in each iteration by adding difference to the current index, by effectively really just computing the total decrements that we apply to this index I and up until this index I. Now, the first thing we have to check is, okay, if nums at I, if it's greater than the current prefix sum, we immediately have to return false. Why is that? Well, because we know if the current value in nums, if it's greater than the total decrements that we actually apply to it, it's impossible to reduce this value to 0. It just isn't possible, because we don't have enough decrements, ranges that include this value to actually decrement it to finally get to 0. And to kind of see that back in the examples here, in example 2, in our input array queries, we know that index 0 does not exist in this range. However, index 0 exists in this range. In the input array queries, there is exactly one sublist or one range of indices that actually contained the decrementing of index 0. And since the value of index 0 is greater than just that one frequency that it has that is contained in the second index, it's impossible to reduce that to 0. Because this, we know for a fact that this index 0 or 4 value, it's going to need at least 4 decrements. And more specifically or more formally, that means that it has to be a valid index in the range of L to R ranges of at least 4 different ranges or 4 different indices in the input array queries to even be able to decrement it 4 times. And in this case, it's not. Only one range of indices or only one index in the input array queries actually contains this possible decrementing of index 0. And so for that reason, we can only decrement it at most once, making it not possible to decrement it fully to 0. And hence, because the value at this index is greater than the number of ranges that actually contain this value to be decremented in our input array queries, we can't decrement it to 0, and hence we have to return false immediately, right? That's why we actually got that difference array initially. That's why we populated it just purely with the queries in the first iteration, and in the second pass, we really just checked and validated each index to make sure that we could decrement it each more times than its value really was, right? Now, again, this was to kind of handle that case if we couldn't reduce nums that add to index 0, we didn't have enough decrementing times or opportunities to do that. However, if we didn't return false for any index in the input array nums in this entire for loop here, then outside of the for loop, once it's done iterating or once it's done executing, we then return true, because if we've actually successfully checked all the elements without ever returning false, that means we can't actually transform nums into a 0 array, and so we would return true at the end of that solution here. Right? So unless I made any syntax 0, 0, there should be accepted, there should be a valid solution. And as you can see, this really is just about as efficient as you can get it to be. So again, on a high level, how are we really solving this problem? Effectively, we're first initializing that difference array to efficiently track the number of decrements that we can maximally or optimally most apply to each index. And for every single query, we'd mark the start and end of the decrement range in the difference array. And then we actually compute the prefix sum of difference to determine the total decrements that we actually apply to each index. And finally, we just really check if each element in the input array nums can be reduced to 0 with the total number of available decrements we have for that index. And if any element or any index cannot, we return false. Otherwise, if all of them can, none of them cannot, then we return true, right? So effectively, we're also handling that fact where we also process all the queries in the most efficient time with really just one pass here, and also accurately determine the possibility of being able to transform nums across all indices into a 0 array to values of 0 or less, or 0 or smaller, if you will, right? So for the runtime complexity of this solution, the overall runtime complexity is going to be big O of n plus m. N is going to be the length of our input array nums, and m is going to be the number of queries. Why? Because we really just have to We really have two separate passes for that. The first pass is for the queries, and the second pass is for the length of the input array nums. And we basically just process each query once and iterate over each input array index once in the input array nums, and hence it's going to be big O of n plus m. And for the memory or space complexity, it's really just going to be also technically linear, big O of n. Why? Because we really only use one extra data structure or one piece of auxiliary memory. That's going to be this difference array, and that's going to have really just the exact same dimension or fixed size of n plus 1. And so that's going to be roughly just big O of n for the memory or space complexity. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.